Here we have a geometry problem. Okay, let's go to the information. In the figure below, AB, line segment AB and line segment DE are parallel. Find CD and CE. Okay, so here there is an information that is two line segments AB and DE are parallel. So whenever two lines are parallel and if there is a third line which intersects both the parallel lines, then it's called transversal. So there are two line segments over here, AE which intersects both the parallel lines, and also there is another line segment BD which intersects both the parallel lines. So the line segments AE and BD are called transversal. And then what is the name of the pair of the two angles I marked over here? So here two parallel lines are intersected by the transversal AE. Then the two line segments are marked over here at the vertex A and E are called alternate interior angles, and they must be equal in measure. And what about the angle measure over here? Here and here. So again, so the two parallel lines AB and DE are intersected by the transversal, the third line BD, and these two angle measures are called alternate interior angles, and they must be equal in measure. So what about this one? So these two angles are opposite to each other at the point of intersection of two line segments. So then these two angles are called vertically opposite angles, and they must be equal in measure. Okay, so the three angles of the triangle ABC over here and are equal to the three angle measures of the triangle EDC over here. Since the three angle measures of the triangle ABC are equal to the three angle measures of the triangle EDC, the two triangles ABC and EDC are similar. So we can write first, let me write the vertex A in the first triangle ABC. So what is the corresponding vertex in the second triangle over here? So already we know that the angle measure at vertex A, angle measure at vertex E are equal. So the corresponding, the corresponding vertex for A in the second triangle is E. So we always have to write the vertices in order. Okay, now let me take the vertex B in the first triangle. What is the corresponding vertex in the second triangle? That is D, because the angle measure at the vertex B and angle measure at the vertex D are equal. So the corresponding vertex for B, the second triangle is D. So let me write D over here. Okay, now the third vertex for the triangle ABC is C, and for the third vertex for the triangle EDC is C. So these two triangles are similar. Since these two triangles are similar, the corresponding sides must be proportional. I mean, the ratio between the corresponding sides must be equal. Okay, let me take the side AB in the first triangle ABC. So here, to get the side AB, I consider the first letter and second letter over here. To get the corresponding side in the second triangle, we have to consider the letters at the same position. That is first letter and second letter. So AB and ED are corresponding sides in the two triangles. Okay, now let me take the side BC in the first triangle. BC means the second letter, third letter. And what is the corresponding side in the second triangle? We have to consider the letters at the same position. Second letter, third letter. So BC and DC are corresponding sides. Now let me take the third side AC in the triangle ABC, and the corresponding side in the second triangle is EC. So AC and EC are corresponding sides. See here, the ratios between the corresponding sides are equal. So that is the corresponding sides are proportional. Okay, now let me plug in the lengths. So for AB, we know the length 9. So we can plug in 9 for AB. And for ED, I know the length that is 6.75. Okay, let me write it over here. So for BC, I know the length, it's 6. For DC, I do not know the length. And instead of DC, better we can write CD, because we have to find CD. DC and CD both are same, equals to, and the length of AC is 13. And the length of EC is unknown, and EC can also be written as C, because EC and C, both of them are same. Okay, here in these three ratios, only in the first ratio I know both numerator and denominator, but in the second ratio I do not know the denominator CD, and also in the third ratio, so there is an unknown quantity, that is CE. Okay, so since these three quantities are equal, we can equate any two out of these three quantities. Okay, first let me equate the first and second quantities so that I can solve for the length of CD. Okay, let me do it. So I equate the first quantity 6.75 equals to 6 over CD. Okay, so my aim is to solve for CD. So better I can take reciprocal on both sides so that I can get the unknown quantity CD in numerator. If I take reciprocal on both sides, I'm getting 6.75 over 9 equals to CD over 6. Okay, to solve for CD, I have to get rid of the 6. So for that, I have to multiply both sides by 6. So then 6 will cancel out. So I can evaluate this one using calculator. Okay, let me do it. The evaluation of this stuff is 4.5. On the right side, we have CD. So I got the length of CD. CD equals to 4.5 units. Okay, now what I'm going to do is I'm going to equate the first quantity and the third quantity. Since all the three quantities are equal, we can equate any two quantities. So because in the first quantity, I know both the quantities numerator and denominator. So if it is equated to the third quantity, I'll be able to solve for the unknown quantity CE. Okay, let me equate the first quantity 9 over 6.75 to the third quantity, that is 13 over CE. Okay, so we need to solve for CE, but it's in denominator. So to get this CE to numerator, let's take reciprocal on both sides. When I do so, I'm getting 6.75 over 9 equals to CE over 13. So let me multiply both sides by 13 to solve for CE. This 13 will cancel out. So now we can evaluate this one using calculator. Okay, let me do it. The evaluation of this stuff is 9.75. On the right side, we have CE. I got the length of CE. So CE equals to 9.75 units.